Hey everybody, thank you for joining us in tonight's Tech Talk. We have Kaden Johnson and Michael Geismar taking us into a deep dive into WebAssembly. Please take it away.
Thank you, everyone. Thank you, Jason. We appreciate you all coming out. So we have a Tech Talk today on WebAssembly, and we would like to start it off by thanking SingleSprout and Codesmith for sponsoring this Tech Talk. Now, as I said, our talk is going to be on WebAssembly. The other name for WebAssembly is WASM, so everybody know that we will be using them both interchangeably. And I will give you a short amount of time to read this joke that we found. All right, so we're going to get right into it. We have 6 questions that we set out to answer here. It's the 5 W's and an H. Who, what, when, where, why, and how. And I will jump right into it. What is WebAssembly? So WebAssembly, from their website, is a binary instruction format for a stack-based virtual machine. It was designed as a portable compilation target for programming languages, enabling deployment on the web for client and server applications. Now, as easy as this is to understand, I'm going to break it down for you. We have a binary instruction format, which they mentioned. What this means is just that essentially all the code is broken down into binary. So when all the code that you bring into your JavaScript gets run, breaks it down into binary, and it runs it for you in JavaScript. A stack-based virtual machine means that just like a stack of plates, you have a last in, or you push things onto the end of it, and you have a first out. So, or first in, last out. So you go in, and then you take it off. JavaScript works off of a call stack, which JavaScript is a stack-based virtual machine. So if you've heard of JavaScript in the call stack, then that's one such example. It's a portable compilation target for other programming languages, so it's very easy to bring programming languages into JavaScript and benefit from those other languages' efficiencies. And it's good for deployment on the web for client and server applications, which they mentioned, which just means that you can bring the efficiency and the benefits of other languages into your JavaScript code for use on the web. And we're going to simplify it a little bit further. What WebAssembly does is it allows us as developers to take code from other languages that aren't JavaScript and input them into your code that can then be planted onto the web for a lot of different benefits that we'll talk about in the future. Who made WebAssembly? So this is the second question we set out to answer. It's just a few small companies. You probably haven't heard of any of them, so I will go through them here. We've got Google, Microsoft, Apple, Mozilla, and the World Wide Web Consortium. And when was WebAssembly implemented? Well, it first appeared in 2017, and very soon after that, by the end of the year, it was actually accessible on all major browsers, Google, Microsoft, Mozilla, and Safari included. Next, I will pass it off to my partner, Kaden, to talk to you about some of these other questions that we're trying to answer.
Yeah, thank you, Michael. So then the question comes, why should we care? As he talked about, it allows us to use other languages in our web applications, but why exactly should that be important for us as developers? So let's look into the benefits of other programming languages. So like, first of all, other languages can have the potential to be very fast. They use multiple ways to do this. C++ and Rust are both considered extremely fast languages. Also, where some other languages are compiled versus scripted, like JavaScript, this allows us to compile it first, which will handle errors before we even have to implement it into our code. And this makes things a lot simpler, and it also makes things a little smaller. And then last of all, other languages have the opportunity to use multiple threads, and us allowing to use more than one thread, unlike JavaScript, we can do a lot faster functions and abilities with more than one thread. So that brings us as to why WebAssembly is better. So when we can compile these languages and use them in our code, we can get a much more constant and faster speed for our browsers. We also save a lot of space. As it is compiled in hexadecimal, it's much smaller than a JavaScript language would be. And then we get to use other languages that people already know of, C++ and Rust being one of the, two of the big ones. And then they're also making their own, known as AssemblyScript. It's very similar to TypeScript. So even if you do not have that knowledge of another language, you can easily pick up AssemblyScript. And then last of all, we can avoid using that bundle.js when we have errors. We can avoid it by just working with, once it's compiled, we know it works. So we don't have to worry about fixing errors in that bundle.js. So, and then the question comes like, how, is it hard to implement? And it's actually pretty simple to implement it. It's all you have to do really is you call it. So like down here in this script that we have here, this code, you call it like you would a node module. Then you just need to wait until it's loaded. And then when it's loaded, you can then use it like you would any other script. It's very simple to implement and easy to use. So here in this one, I brought in this graph, which kind of explains in what ways we should use it. So this graph, they made a function, they made functionality to take an image and rotate it. And so they first did it in JavaScript. So we can see over here, they have their runtime. So as they moved from browser to browser, you can see that they started off with good speeds, but as they went to other browsers, they got really poor speeds, up to 8 seconds just to rotate an image. But then they took this same functionality, they built it in C, AssemblyScript, and Rust, but they pass it in using WebAssembly, and their times were not only usually shorter, but they were also very constant. And this is really good for developers because if we can kind of guess the often amount of time it's going to take to run something, we can make a much better user experience for the people using it. And so then we can kind of go into like, what things is it good for? We don't want to replace JavaScript. That's not what the goal is, but we do want to use it for some specific things. Bottleneck functions, audio, video, image, and animation files are massive, and it's a lot easier to work with in these other compiled languages versus doing it in JavaScript. And lastly, just any code that's very computationally intensive, we could use WASM or WebAssembly to just make the process a little bit faster and a little bit more constant, and easier for the computer to handle. So, that's a lot of like dense stuff. So let's talk a little bit about where it's implemented now. It's, as Michael said, it was released in 2017. So it's not that old, but people have implemented it and it is being used more and more every year. So the first one is Unity. They're a game engine company, and they allow people to create games. So what they did is they have WebAssembly used to take games that you want to build and you can easily port them to the web versus having to run it on your local machine. Another big one, Unreal Engine, the big creators of Fortnite, they are doing the exact same thing. They're using WebAssembly to work with the web as well as keeping their local version. And then another one that some of you developers might know is Figma. Figma allows us to model out the idea of how we're going to build our sites, how we want the user experience to be. And when they used WebAssembly, it actually decreased their load times by 3 times versus when they originally had it in just plain old JavaScript. And I'm going to pass it on to Michael to talk about a few more.
Thank you, Kaden. So we have Google Earth here, and Google Earth was implemented with WebAssembly. And if anyone remembers the years when Google Earth was only usable on Google Chrome, well, that is no longer. So Google Earth, as of 2020, was brought to Firefox, Safari, Edge, and as it already was, Chrome. And that's purely because WebAssembly was implemented in those browsers, and WebAssembly and its ability to work with Google Earth made it so that Google Earth could be used on what was formerly a browser that was too slow. Now Google Earth works pretty evenly across all browsers, which is really awesome. And the next one, the last place where that it's implemented that we're going to talk about is in Ableton. For all of you music producers out there, or for anybody who doesn't produce music, Ableton is an application that you can produce sounds and make songs in and master them in. So Ableton and their dev team created a synth learning lab online. It's really, really awesome. But what it does, in their own words, is the generating of audio from synthesis does a ton of heavy computation of math and algorithms. So the performance benefits of WebAssembly relative to having to write web apps in JavaScript means that a whole new class of web applications can now be accomplished. And just to exemplify that a little bit, I've created a demo for us, or found a demo for us. So everyone, just as a disclaimer, this is going to be potentially a somewhat loud sound. So if you have your audios loud, just be ready to turn them down a little bit. So this is their synth learning lab created by the Ableton dev team. And if I move this around, you'll see it's very reactive. So keep in mind, this sound is coming from my computer into Zoom into your computer. And you can see how reactive it is as I move this circle around the screen. And it's really awesome that they implemented WebAssembly in this. So just one more time, I'll show you how reactive it really is. And now, if we're going to take a deeper look, we can inspect this page with the dev tools, and we can look and see, oh, look, they have this script right here at the top. And if we open up that script, we can actually see that this is where they're checking if the browser is compatible with WASM. So right here, they check, is the browser compatible? They have this function, they break it down, they do all these checks, and then at the end, they tell you whether it's compatible or not, and they can run this based off of whether it's compatible or not. And then if we look a little bit deeper into their music lab, what they actually use to create these sounds and synths on the page, when we open this in the sources, prettify it so that we can all understand what's actually going on here. And if we do a little find and we say, all right, well, WebAssembly, let's look at that. And you can see there are over 20 instances of WebAssembly just in this script code right here. And then if we go a little bit deeper and we say, all right, well, what if we want to look up WASM? Well, they also use WASM, which is some form of separate call and functionality, even though they're the same technical term, and they have this a lot of times in here as well. So as you can see, WASM and WebAssembly interchangeable, used in this application very heavily in order to produce the sound and the computational data that they need. So that's enough for the demo part. We're going to move on to a summary, and now that we've answered all our questions, I'm just going to try and break down a few simple questions that'll help remind you of everything that we've talked about. So who created WebAssembly? Just the small companies I mentioned earlier, being Google, Microsoft, Apple, the World Wide Web Consortium, and Mozilla. So those are the 5 companies. Why was it created? Well, it was created in order to solve the issue that the web and JavaScript can't run code as fast as some other languages that you need to do a lot of computational work. So when that work needs to be done, how are we going to do it on the web? And the way that it works is that you can just take those benefits from other languages by, if you can imagine a JavaScript function. So let's say we call that function compute, and that function is in JavaScript, but the code inside of the curly braces in the JavaScript is actually a different language. And when we call that function, so let's say we call compute somewhere else, well, that code in that other language is broken down into binary by WebAssembly, which allows it to take the benefits of that other language bring it to the web, do the heavy computation the JavaScript is a little bit slower at. And that's how it works. So for our last slide, this is the end of our matrix. Where you go from there is a choice that I leave to you, as Neo said. And a little bit of about us, some of the references from our page, and that is the end of our talk. Thank you all for listening.
All right, let's give it up for Kaden and Michael.